Welcome to another session of the epidemiology. We are gradually talking about the most basic principles in epidemiology. And last time when we met, discussion was oriented on the research methodologies, in which we identified several research methodologies under the titles of observational epidemiology or experimental epidemiology. Observational epidemiology is very commonly done. It is cheaper, it is easier, and that's why we shall be focusing on it much more. Experimental epidemiology is a bit costly, it requires time and money, resources, and that's why it is not much used at the basic levels. But still, we should know about that. So, in observational epidemiology, we had two major classes: descriptive epidemiology and analytic epidemiology. We would like to go into more details because these conditions are often asked in the examination and are of frequent use in the practice. Even if you become a medical officer, a district health officer, a physician in the hospital, you need to know about the descriptive epidemiology and to some extent analytic epidemiology. These are again, I try to repeat often because you remember it is observational epidemiologies. Okay. In distribution, we were talking about three major factors to be distributed. Any case is distributed in time. We have to mark in which year, in which month, in which particular time. For example, the COVID-19 had been in China since December onwards. We started having experience of that condition since January 2020. So this time is very important. When did it happen? So time distribution is the most important distribution out of three: time, place, and person. Time is most important because there are several conditions which follow the time trends. And because we know that it will happen at a particular given point of time based on our experience and observation, we can start planning for the prevention or control, isn't it? Any administration will require when will it start? And if we are ready for the answer that yes, so and so disease will start in monsoon, the planning of its prevention can start in monsoon. Now, in such time trends, there are several distinct classes. Some of the diseases are having, say, short-term fluctuations. They fluctuate. They rise in a given particular time period. Then again, they do not do. They disappear. Then after some time, they may appear. They may not appear. The typical example is an epidemic. Epidemic takes place generally for a given point of time, given period of time, and it may not occur once again. For example, in 1994, plague epidemic was present in Surat, but thereafter we did not listen to that, and it was only for the month of say October, November, December of 1994. Thereafter, we could not listen. We could not have any experience of that disease. So, time and in that also some short-term fluctuations. That's the one thing. Second class is generally after short-term periodic fluctuations. There are certain diseases which have periodic fluctuations. They come at a given point of time, given period after some time. And third part is of course the long intervals or consistently they are happening. They continue for years to increase or years to decrease. Such conditions are known as the long-term fluctuations. In short-term fluctuations also after the epidemic, there are several classes. Say there may be a single exposure. Single exposure. The disease agent antigen has come. The agent has come. And this is known as point source at a given point of time. I have given the example of the plague. It was almost like that. So generally this is true in case of the communicable diseases, infectious diseases. And all of a sudden we start having cases, they go on increasing for some time, they reach a peak and they start declining. This particular picture is for the single exposure. For example, today several people have taken a dinner and there was some food poisoning. So the cases will start coming after 1 hour or so, and they will continue for say 5 hours, 10 hours, and after 1 day or so, again the cases will stop coming. This sort of small epidemics are more usual in the single exposure or point source epidemics. Now, the second one is multiple exposure. Say the disease occurs, then again it subsides for some time, or it may continue after a small break and then comes again. So this is known as a continuous epidemic. Continuous epidemic. Both these cases are very frequent. For example, polio continues to be present in one form or the other. Now we are in the verge of eradication of polio. But as far as the past experiences of the polio are concerned, a particular area is affected, then after some time another area will be affected, and that continuously almost goes on. So this is because of the source, which may be several sources. A very odd example is a prostitute. Suppose she is transmitting the sexual disease to her clients. Now, clients will go on changing. They may be coming from the different places also, and they go with that particular sexual disease. And this sort of epidemic, increasing the number of the cases, will be of the continuous type. In the single exposure type, the epidemic curve rises, falls rapidly, generally, and there is no generally secondary control. There is no secondary cases. The same source X generates the cases go on increasing, reach a peak, and then it declines. Now, all cases will be usually over some time, and the interval will be minimum. Usually, infections subside of its own in most of the cases. For example, another big example which you want to take it is in Bhopal, there was a gas tragedy. And after that gas tragedy, several deaths occurred. There was really a cry that many persons have died, many have been blind because of that gas. But then that was once upon a time, that's all. No such tragedy occurred again. Such single exposure point interpoint epidemics are very common in history in forms of epidemics. The second part was multiple exposure, which I told that like the plague, the situation continues to happen like that. But in some cases, like say in cholera, the cases start occurring, newer and newer patients will be coming from different areas where the consumption of that infected or polluted water will be there or polluted food will be there, and gradually they go on declining. It is not like a peak coming in the single source, but like a multiple source, the peak comes and gradually it declines. This gradual decline is because of the many different patients coming into contact of the exposure or the agent. This is to be remembered, and this is known as the short-term fluctuation. The second part, with the seven we have said that single exposure, second is multiple exposures, and third is propagated epidemic. Now, propagated means the current one which we are talking about, say COVID-19. It spreads from person to person. So it goes on continuing for several times till the susceptible population is infected with it, or the control measures have been successfully taken for it. This may be because of the arthropod or the vectors leading to the transmission of the disease. It is very necessary that the transmission of the disease takes place from one case to another case to another case, and that goes on. There is no propagation. That's why the name is given propagated epidemic. And the third one is the slow epidemic. And these slow epidemics are for this modern epidemic. They continue for the long time. Can you recall the coronary heart disease? Gradually the cases are increasing since last 50 years. And there is no point that has declined. Every year they go on increasing comparatively. That's why these three types, if you remember, out of the short-term fluctuations, one is the epidemic of the common source, second is the propagated, and third one is the slow modern pandemic. Now, in propagated epidemic, what happens? I have already quoted the example of the COVID-19 with a clear understanding that initially the agent enters into a community where there are susceptible hosts. They have no experience of that disease or minimum experience of that disease. So all those who do not have experience, they will be infected. They may not have the disease as a case or signs and symptoms, but they will be infected. Once they gradually build up the infected individuals, there will be a peak. And once the people who are infected, they have immunity, you will find that at the peak level, about 50% of the individuals are already infected and they have some immunity. Gradually, this immunity, the people with the immunity will be increasing. This is known as herd immunity. And then the infection dies. Gradually, the curve comes down. This typical curve is that of the propagated epidemic. And once you know that, then you can easily divide them into three parts: initial phase, peak phase, and then declining phase. Or you can say termination phase. These are very important because if you want to stop somewhere, you should start acting immediately during the initial phase when the cases start happening. You need to control those who are in contact with the affected person. This happens to be in the most infectious cases, and generally there is a need of the person to person transmission. We have quoted several examples. Hepatitis A or polio are the other examples. Then there is some conditions which are very required. So there has to be some transmission conditions should also be necessary till all susceptible persons are infected. Now either you protect them or you allow them to be infected, whatever is your choice, depending upon the severity or virulence of the disease. Now, where large number of susceptibles are aggregated, for example, there is an island. No one has experienced disease X on that island, and all of a sudden the disease comes there. I think 100% of the individuals will be infected because they do not have any antibody or a resistance to that particular disease. And secondly, there has to be regular supply of the uh, new susceptibles. Suppose in that island, those were newborn people. Even after the entire population getting infected, the newborn persons, newborn infants, will be susceptible. So for continuity of the disease, what is required is, number one, there has to be susceptible hosts. If they increase, there will be more and more cases. And if they decrease because of either of the experience of the disease or vaccine or whatever it is, then gradually the disease declines. Then you can see some diseases are having this seasonal trend. Seasonal trend in that particular, what we have seen as propagation. Dengue, for example, dengue is propagated by the mosquito. Whenever the mosquito density, mosquito population increases, the cases of dengue will also increase. This may be known as a seasonal case, but again it is an example of the propagated disease, propagated by a vector. The second part, first one was the short-term fluctuation, second was periodic fluctuations. Earlier, when measles vaccines were not so many, there was a history that measles took place, the epidemic of the measles took place every second or third year. Why did it happen so? Because the susceptible number of the children for the occurrence of a possibility of measles must be enough. And that build-up will be at the end of 2 years or 3 years. Newborn children will come up, they are not vaccinated, they will be infected, and there will be a peak again, 2 years or 3 years. In the interval period, the children who are already there, they must have been infected by measles and they are already resistant to that. They have antibodies to fight it out. That's why this is important. Now, periodic fluctuations may happen seasonally, and you know which are the seasonal occurrences, like say upper respiratory tract infections. They always happen to be more in the winter. Gastrointestinal tract infections and diarrhea, more in the summer. Now, this may be related to temperature also. Temperature, humidity, life cycle of the vectors, rainfall, overcrowding. These are the other factors. which play some role, but ultimately they are happening periodically, and that's why we can predict them. One can easily predict malaria happening after June because new, say, rainfall will be there. After rainfall, there will be collection of the water. In collection of water, the mosquitoes will breed, and we expect that there will be more cases of malaria. So, environmental factors as well as the vectorial factors also play some role. Even in non-communicable disease, like the snake bites, will increase in summer because snakes will come out of the ground and likelihood of the snake bites increases. Similarly, there may be, say, sunstroke. Sunstroke is in summer, though it's not an infectious disease. This is non-communicable disease, but it will take place in the particular season. So all these conditions are known to be having a periodic fluctuation. In non-communicable disease, say in United States, I do not know whether that is true in India or not, but at the weekends, the accidents, vehicular accidents, automobile accidents are much more, particularly on Saturdays. This is related to the density of the vehicles and accidents. So such non-communicable diseases can also happen to take place periodically, maybe at the end of the weeks or months or years, whatever it is. What is the fun of studying it? The moral of the story is if we know about when the disease will occur, we can plan for the prevention. We can prepare ourselves for the control measures. And if we do that, perhaps the deaths can be avoided, the disabilities can be avoided, and more morbidity can be avoided. The last one is the long-term fluctuations. Long-term fluctuations are also known as secular trend. Secular means occurring over a long period, maybe years most of the times. And these are, say, I have given some examples: coronary heart disease, lung cancer. Lung cancer is also one of the conditions where diabetes mellitus is increasing day in and day out. These are also known as hidden epidemics because of their nature, generally they do not come to the notice of the people. Most of the times people themselves do not know that they have that disease, but they are occurring, and gradually during last 50 years they have been increasing. Now, if this is a long secular trend, there are certain diseases which are decreasing also with the time. For example, now cases of typhoids are decreasing day in and day out. Every year we find less cases. So is true with the diphtheria. Earlier diphtheria cases would be in thousands when the country became independent. Now even if there are 10 cases, we are worried about that there are cases of diphtheria. So with the passage of the time, large number of communicable diseases are being controlled and they are reducing in numbers, and that's why that is known as a secular trend. Similarly, very good number of the non-communicable diseases are increasing in number, and we have to prepare for more and more cases in the days to come. So what epidemiologists must be doing after learning the time trend? Suppose somebody asks a question, what are the lessons to be taken from the lesson from learning of time factor in the epidemiology? One, let us know whether it is increasing or decreasing. There may be neither a disease increasing or decreasing, but a new disease must be emerging. So once should find out whether the disease is decreasing, increasing, or new disease is coming up. Accordingly, the preparations will be started. Number one. Two, what is the impact of our strategies, whatever we are planning, whatever control measures we have already planned and now we are taking, whether they have been effective or not. That will be clear based upon the notice of the occurrence, how many cases occurred according to our prediction, whether they occurred or not. That is the second thing. Third one, this may increase or decrease because of several other reasons also. Suppose the method for diagnosis has improved. You will find more cases. Earlier you were not knowing it and you could not report those. Second one, suppose reporting has increased. Earlier the reporting was not given by sub-centers or primary health centers or peripheral centers. Now more and more tests are being conducted. What has happened in COVID? In COVID, we are reporting new positive cases because more tests are being done. So, with the improved technique of diagnosis, more and more tests, and more reporting, we will find that actually the disease is found to be increasing. And that's also a good sign that we can control it in right time. We should also note whether the case fatality is also increasing. That is, the number of deaths per 100 cases or 1000 cases is increasing or decreasing. That will talk about the virulence or change in the virulence. The disease situation may improve or deteriorate based on the environment also. Some say that viral conditions are reducing in the temperature, in the increase of the temperature. If that happens, then there will be decline in the number of cases. Similarly, this may happen because of the change in the age distribution. Italy had large number of cases of the old age people, while India has many young people. This will also make a difference in the case fatality rate in a disease where old people are more likely to be affected and may die. So these are other factors which may lead us to say if there is change in the quality of life, if the overall development of the country has taken place, certain diseases will decline. Last time I have told that in developed countries, the communicable diseases had declined long back before our country became independent. And that was because of the improved lifestyle, improved life situation, quality of life. And that also leads to better conditions for survival and removal of the communicable diseases. So observations will help us. What are we observing? Time, place, and person in main. And today we have discussed about the time factor. We will be discussing about the place and person factors to complete the trio: time, place, and person, or the answers to who, where, and when in epidemiology. So far, so good. Thank you.